Okay, Assalamualaikum and very good morning to all. So today we will continue our next lecture, okay, on this pneumatic and hydraulic actuator system, okay, on the part number 2, okay. Okay, so we already learned on the overview of the hydraulic and pneumatic actuator systems. Okay, so you will get an overview what type of pneumatic and what kind of hydraulic actuator that have and that can be used for the mechatronic systems, and also some of introduction to the valve type of valve. Okay, so basically for the today lecture, on the is more detail on the detail of the valve itself for both pneumatic and hydraulic system. So basically it's under 2.3. The chapter is on the directional control valve. Okay, so inside this section there will be a valve symbol. Okay, the detail on valve symbol, the various valve symbol that can be used in the pneumatic and hydraulic actuator. And the second one is on the pilot operated valve, okay, which is can be assist. There's an issue on the very strong system that need to assist by the pilot operated valve. And finally on the directional valve. Okay, so basically pneumatic and hydraulic system use a directional control valve, okay, to direct the flow of fluid through the system. Okay, so this is example of valve that we use in the pneumatic and hydraulic system. Okay, so basically this valve is not affect the flow. I mean there's no control of flow rates. Okay, the velocity of the flow, but it's just an open and closed system lah. Okay, which is like a on off switch. In that you on and the flow will go, and you off the flow is stop lah. Okay, so it's better for the to set for the sequence of the control system. Okay, sequence 1 2 3, and also to give a proper direction control for the flow. Okay, so this is the one example of a common directional valve. Okay, this is a spool valve we call it. Okay, so this is movement in terms of horizontal movement. Okay, this is the spool. Okay, this is two stage, okay, or two positions, okay, which are three ports. Okay, so basically after this I will show you how you can write the symbols of like this. This is a 3 by 2 valve, okay, where there's a three ports and two condition or position of the movement. Okay, so basically this is the first condition, okay, when the port 1 for the air supply is opens, okay, and then is go through this port 2. Okay, so port 2 is basically is connected to your system lah, to move like the hand robots or everything. Okay, and then after that the spool will uh, horizontally move, and then it will close port number 1, and it open port number 2 and 3. So this will release the air to the atmosphere, okay, to vent the air to the atmosphere. Okay, so that's basically the principle of this spool valve. Okay, so this also that we call it a rotary spool valve. Okay, it's a rotating spool here. Okay, instead of it's move horizontal, it can rotate, and when it's rotate, it will open and close the port similar way lah, the way of this horizontal spool valve. Okay. Okay, the next one is a it's more quite simple one. It's called a Poppet valve. Okay, so this is like previously is a three ports, but this one have only two ports, and also the same one two condition of operations. Okay, so basically there is no connection between port 1 and port 2. Okay, such as what we previously shown that this is have the connection of port 1 and port 2, port 2 and port 3, but this one there is a separate. Okay, so the connector can be in terms of balls like this, and also this or cone in shapes. Okay, so basically this when the button is pressed, okay, this is condition of non-press, okay, the valve is closed. When it press, and then it's the air supply uh, can be flown towards the your system lah. Okay, the output number 2. Okay, so we go to the detail of the valve symbol here. Okay, symbol used for the control valve consists of a square for each of its switching position. Okay, this is the square. Okay, that mentioned for each of switch position. Example, we take as a poppet valve here. Okay, so basically the first condition we write on the right side, and the second condition we will write on the left side. Okay, so basically this is a condition of button not press. Okay, so this is three mains of blocks that basically use. Okay, the A1 is on the directional of the airflow. B is the close condition here, the T symbol like this, and the C1, the connection ports, mean that if have four, there's four ports lah. Okay, so for this one, okay, so basically this is some of description. The ports are labeled as 1 or P here, like this, 1P for the pressure supply. Okay, when the pressure is supplied, 3 or T for the hydraulic return. Okay, this is most for the hydraulic actuator. 3 or 5, okay, or R or S is for the pneumatic exhaust. Okay, this is basically we have in solenoid 1. Okay, I will show you after this. And 2 or 5 or B or A is for the output ports. Okay, is the output ports here lah. Okay, let's see here how it's function. Okay, so basically when the pressure is applied, okay, this is the closed condition. The first condition you see here is not connected. Okay, is two of the port is closed. Okay, so this is supply of the air, and this is 2A is the output. 2A for the outputs, 1P is for the pressure supply. Okay, so if we press the button, it will move here. You can see that port 1P and 2A is connected, and then this is the directional of the airflow. Okay, we see after this. I show you more detail. Okay, so this you can use a various symbols, okay, that indicate a various way of the valve then can be actuated lah. Okay, so basically for this one, the poppet one, we use a push button, and for the solenoid, okay, for the spool, okay, we use a solenoid. Okay, so instead of that, you can use a plunger, okay, a lever, roller, pedal, okay, the application of pneumatic pressure, and also the spring. Okay, so this is the way how you can write your valve lah, symbol, which is 3/2 means that you have a 3 ports, okay, and 2 position. Okay, the spool one, for the uh, poppet is a 2/2 lah. Okay, also you can write like a 5/3 when the system have 5 ports or 3 position lah. Okay, so this is the how you can write position 2 blocks, and 3 position have a 3 blocks. Okay, for the 2 ports 2 position valve, okay, as a poppet valve, is described as a 2/2 valve. Okay, so basically for the poppet valve, it will described as a 2/2 NC valve, mean that normally closed. Okay, the original condition, 2 of the port is normally closed. Okay, so this is the first condition, and this is the second condition. Okay, when it moves to the second condition, okay, the symbol 1P and 2A we write here, so that is a flow towards the open condition lah. Okay, the arrow here, okay, as indicate, is a use for the flow directions. Okay, the external port is not connected, it is shown as a T symbol like this. Okay, so it's also the symbol under net square represent as a air input like this, and also this triangle shows as a exhaust. Okay, so this is the how the the animation one from the 2/2 valve and the closed condition. Okay, when we open it, okay, it will move. Okay, so the as shown in the visual before this, it have a push button, and also the mechanism is using a spring. Okay. Okay, let's go to the next one. Okay, it's previously shown to you the spool. Okay, the solenoid operated spool valve. Okay, 3/2 and its symbol. Okay, this is the condition of the first condition. Okay, this is considered NO. Okay, which is normally open. Okay, which when it normally open, you must also always refer to the first one, the 1P here. Okay, mean that's it. The first condition is always open lah. You can have a airflow, okay, in the blue one to the green one. Okay, and the port number 3 is currently closed. Okay, there is no activity here. Okay, as the solenoid is generated by the electrical, and the spring is moved towards these positions. Okay, so that you can see the port number 1 is currently closed. Okay, okay, from this one to move to this one. Okay, so currently this condition at this stage, port number 1 is closed, and this port number 2, okay, move to the exhaust port number 3. Okay, 3R, that's the thing lah, that is the exhaust port is we mentioned as a 3R. Okay, okay, this is another symbol for the 4/2. Okay, where there is a 4 ports. Okay, 1P, 2B, 3R, and 4A. Okay, and there's a two condition, okay, before and after activation lah. Okay, so this is before the activation. Okay, after the activation, how it's happened, okay, you can see over here. Okay, so this will be the condition when the after the activation lah. Okay, you just move this symbol. Okay, just be remind that the symbol must be in the same position lah. When 1P here, when you move, it's here lah. 3R must be at its position. 4A from this to this, and 2B from here to here. Okay, you cannot make it opposite one. Okay, you just must stick at the previous position like this. Okay. Okay, this is some of the example of the pneumatic system operation, or as I have mentioned previously, attached also in the e-learning website on the video how the some of pneumatic actuator that can be operate. Okay, you can see there the video and try to understand practically how it works. Okay. Okay, so this is for the first activity for you. Okay. So basically, the question, okay, in the examination or test can be asked like this lah. Okay, you need to draw the pneumatic symbol for example 2/2 NC valve. Okay, 2/2 NO valve. Okay, maybe 3/2 NC valve and 3/2 NO valve. Okay, so as explained before, the NC is normally closed lah. Okay, when the original condition is normally closed as what we have in Poppet Valve. Okay, and NO is normally open. Okay, when the original condition is basically in open lah. Okay, I mean you can refer to symbol 1P. Okay, is C or O lah. Okay, that's one you can in for normally open we can have like the spool one, the solenoid of the spool valve. Okay, so the question asks label all the ports on the valve. Okay, the valve is activated by the push button and has a return spring. Okay, so you can also try alternatively by using another type of actuator activation lah, like the symbol that in the previous slide, using the solenoid. Okay, it's a roller, plunger, or etc. Okay. Okay, there's another symbol, a function that we call U as U, okay, which is universal. Okay, and pressure supplied to any one of the port lah. It's a quite general one, the universal one. Okay, but most of time we use these two, NC and NO. Okay, let's see the some solution. Okay, this is some of the marks that can be given if you have done the correct way. Okay, for the 2x2 NC valve, okay, normally close, and for the normally open is opposite lah. Okay, and same goes to this 3/2. Okay, have a 3 ports. Okay, and normally close one. Okay, you can refer in 1P. Okay, is normally open, is must have a connection of movement lah at the first stage, like what we have on the spool solenoids. And this is normally closed one. Okay, there is no connection here. Okay, okay, so this is another activity for you. Okay, the figure shows a simple pneumatic lift system. Okay, this is a pneumatic lift system which a two push button. Okay, 2/2 valve are used. Okay, mean that's there. This is 2/2 one, and this is 2/2 two. Okay, this is two push button of 2/2 valve that being used. Okay, explain what happened first when the valve A is pressed and held. Okay, so the hint is very simple. When you push, okay, the load is going up, and when you push this down, and the load is going down lah. Okay, so by that hint, basically you should able to explain all of others condition lah in 2, 3 and 4. Okay, so maybe this one you can have a try and think, and you can discuss with your friend also, and refer some of the reference at how it works based on this direct question. Okay. 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 So we move to the next one. Okay, is on the pilot operated valve. Okay. In a pilot operated system, one valve is used to control a second valve. Okay, this means that they have two valves. Okay, when the force required is too strong. Okay, when you have a system that requires a high force to move, okay, the actuator is not sufficient to move any of the system. Okay, maybe the load is too strong. Okay, too high, so you need like a pilot operated system. Okay, this is the pilot operated system. Okay, the first valve is called pilot, and the second valve is called the main system, the main valve. Okay, so it's connected by this dot line. Okay, okay, when this is basically closed condition. Okay, uh, okay, and then when it's starting to works. Okay, the P have a airflow directions. Okay, using a solenoid and spring, return spring, and it's connected to this dash. Okay, the pilot pressure line. Okay, and then after that, the system of the main valve is moved. Okay, that's basically the simple animation of how it operates. Okay. Okay, the next and the last one for this lecture is on the simple directional valve. Okay, and how we can draw its symbol lah. Okay, so basically for the simple directional valve is just allow for a one direction lah. Okay, this have a symbol of the ball and a spring. Okay, as you can see here, okay, you can easily understand when the flow is pressured here. Okay, this is possible of the movement when there is press the ball here, and the ball will move, the spring will move, and the air will flow. Okay, so the flow in this direction is a one-way flow. Okay, you can see the direction when you have this valve. You can see the arrow direction. Make sure you mounting in the correct direction lah, so that you can move the flow. Okay, there is no possible for the direction lah, as you can see here when the air, because the spring is always force the ball to this end direction, so there's no ways that the flow can be go through this hole. Okay, so this is the symbol. Okay, this is the symbol of the flow going here, and this is non-flow. Okay, so basically for this directional valve is a check valve for a one-way valve only lah. Okay. Okay, I think that's all for today class. Okay, thank you very much. Okay, see you in the next class.